everyone. Welcome to Dr. Frank's Finance World. I am Dr. Frank the Bank, and tonight we're going to be doing problems, which is what part 4 of the risk and return is all about. And that'll help you gain some comfort, I think, to get it right at test time or in real life. So we're going with the probability of a plum company sales next year. This is actually where it starts for a lot of businesses, is the salespeople, the marketing people will actually tell them how much they expect to manufacture. From there, they derive how much to produce and how much inventory, receivables, and all the rest. So it's actually a pretty important part of the process. And you can do it once again based on the probability. So in this case, we have a 50% probability that they will have sales of $12 million or more during the year, a 20% chance that they'll have $7 million or more, or $7 million actually, or a 30% chance that they will actually have $3 million. So there's your 50, 20, and 30%. There's your 12, 7, and 3 million. And once again, to get the expected sales, all you have to do is multiply across and add down. So when you take half of 12 million, you get 6 million. When you take half or 0.2 of 7 million, you get 1.4 million. And 0.3 of 3 million is 0.9. When you add it all together, you can expect next year to make about 8.3 million in sales based on those estimates. Of course, it says what is the standard deviation of their sale. So you have to go in there and calculate the variance, which is going to be the probability times the actual. Remember, this is the actual minus the expected squared. Probability 0.2 times the actual minus the expected squared, and then the 0.3 times the actual minus the expected squared. When you run through that, you actually calculate this. Calculations here will come up with a variance of 15.61. But when you take the square root of it, you get the standard deviation, and indeed you have it as $3.95 million. There's easier problems too. I've done this many times for lottery. I think it helps to understand why people would buy lottery tickets when lotteries get to be a certain amount with the probability of loss, and well, you have almost guaranteed you're going to lose your money, but it's really the gain people are looking at. In this case, we have a lottery ticket. If it costs $1, what's your probability of winning? And you have to presume, of course, you're the only person that wins it. But if it's got a $30 million prize here and only 1 in 62 million, remember it's the probability times the outcome. And when you multiply that across, you end up with 30 million divided by 62 million. And you find out that in this case, the $1 lottery ticket is worth 48.39 cents. So as usual, it is a lousy investment. But I still play sometimes when it gets really big. All right, so this is the risk and return part that talks about the required rate of return for a firm, and we're going through and using the CAPM equation here. And so we can show over here that we have the CAPM is equal to the risk-free rate of return plus beta times the return of the market minus the risk-free. So in this case, the risk-free return was 3.5%, so we fill that in here. And the beta was 2.3, so we take 2.3 times whatever the market risk premium is. And to calculate that, we take the return to market, which we said was 7%, minus risk-free. So this becomes 3.5% in here. When you take 2.3 times the 3.5% and add the 3.5% to it, you get a required rate of return on that stock, or a CAPM of 11.55%. Says, what if you knew the required rate was 17%? Now I'm giving you, and this is pretty common. I actually do this on exams too. I give them what the required rate of return is and make them solve for something in between. So it's 17% required rate of return. The equation is still the same, risk-free plus 2.3 times the return of the market minus the risk-free. Interestingly, we can multiply across, add up and multiply across, or we can multiply across and add or subtract and get exactly the same answer. So we have the 17% over here is still equal to a risk-free rate, plus when we take 2.3, multiply it by the 7%, we have 16.1%. And we move across here and multiply 2.3 times the risk-free, and we have a minus 2.3 risk-free. So when you put this through and you bring this over to the other side of the equation, you have 17% minus 16.1 gives you a 0.9% over here on the left side. And we have that it's still the risk-free minus 2.3 risk-free, which actually gives you minus 1.3 risk-free. And when you solve for that, you find out that the risk-free rate of return is minus 0.692%. And you go, gosh, that could never happen. And yet, there were negative yielding bonds in Europe for numerous years recently. So actually, it could be negative, at least on a certainly inflation adjusted basis. All right, there's another way of using sort of the empirical rule and this sort of bell-shaped curve and stuff to figure out other type problems out here. And I think that's really the power of it all, is because this time we're looking at a scale down here that is not returns, but is actually units of toilet paper. In Arkansas, when I lived in Conway, they actually did have a toad suck festival, and they had a lot of carny kind of food, which could definitely lead to the use of large amounts of toilet paper. But basically, they're asking, here you are at a Kroger store saying, should I load up on toilet paper for toad suck? And the answer is maybe. And remember, in this problem here, we're saying that the mean amount that you sell every week is 600 units. How many would I need to order over here to make sure I wouldn't run out very often? And that's kind of a nebulous term here, but we're saying that 2 standard deviations out would be okay. And the reason why is because you would have 97% of the observations fall this way. In other words, you had enough toilet paper for everybody 97% of the time, and 97.5% actually, 95 plus the 2.5% over here. And the other 2.5% of the time, you would not have enough, but you're willing to risk that sellout of toilet paper and people not having the right amount. So the question then is, how do we find it on the scale down here? What we're going to do is we're going to take the mean and add and subtract 2 standard deviations, really only add this time because we don't care about the low end. So we take the mean of 600 units multiplied by 2 times the standard deviation. How do we find the standard deviation? Well, they gave us the variance. All we had to do is take the square root of it. So 72.46 units is actually what 1 standard deviation is. So when we take twice that down here, you're ordering 744.91 units or 745 units because you can't order 0.91 unit of a toilet paper package. And you would only run out about 2.5% of the time based on the empirical rule. So it's a really useful thing. I've seen people use it for fill rates of bottles on an assembly line. You can look at failure rates of parts when they do checks of quality checks on different things, computer chips or whatever. So it's a very, very useful tool, and I'd highly recommend that you do it and use it out there in the future. All right, so there's another problem. It says a portfolio earns on average about a 10% return. So here we have the normal distribution, and the average return down here, the top part of the distribution is 10%. If the standard deviations on stocks was 5%, what is the probability you would lose money on this portfolio? Well, the point that you lose money on the portfolio is when you're making a negative return. So something below 0 is what you're looking for. And the question is, how much of the distribution falls that way? Well, if you take 10% and each standard deviation is 5, you subtract 1 standard deviation over, you'll find out that it's still on the scale down here of returns is still at 5%. So you can still see that you are indeed in the positive return. So if you go 1 more standard deviation or 2 standard deviations over, you now take 5% and subtract the other standard deviation of 5%, and you end up with a return of 0. So therefore, you know that indeed past 2 standard deviations is where you'd lose money. If this is 95%, you're going to lose 2.5% over here. So the odds of you losing money are actually about 2.5%, which would be great in the game of stocks, to be honest. Finally, one of the more difficult ones is we did a problem earlier here where we had a 50% in each stock, but the reality is the weighting in the stocks can matter. And one of the things I said back then is form a portfolio, and that is true now. I took exactly the same probabilities, exactly the same returns that we did in a previous problem, but instead of 50% of each, we're going to take 70% of stock A and 30% of stock B. So I'm forming the portfolio right here in this area right here. And so I take 70% of the 20% and 30% of the minus 11%. And then I take 70% of the 10% that's weight-wise, money-wise, and 30% of it is going to the plus 5%, and finally 70% of the minus 4.3, the weighting times the 18%. When you see how the addition and stuff goes over here, you actually have a probability of for portfolio MB of 10.7, 8.5, and 2.6%. So to find the expected return, you simply are taking 0.5 times this 10.7. You're taking 0.1 times this 8.5. And the remainder of the probability is 0.4 times the 2.6. You get these component values. When you add them up, you can see that the expected return for the portfolio is actually a positive 7.24%. So if we want to look at the variation of the variance on it, or the standard deviation, we're actually going to have to do the standard deviation equation, which is what we're doing right here. The sum of actual minus expected squared times the probability, just like we did in other problems. But this time, this is the portfolio right here. So the actual is 10.7 minus the expected 7.24 squared times how often it occurs, 50% of the time. Then you can look down here and say the next one was the actual, which was 8.5%, minus the expected of 7.24 squared times its probability. And finally, the 2.6%, the actual, minus the expected of 7.24% squared times that probability. You end up with these numbers down here for the variance. And then when you, actually the variance, and you end up adding them together, and you have 14.78% is the variance. When you take the square root of that, you find out that the standard deviation for this portfolio is actually 3.84%. So finance is a process. Learn the process and you will get the problems right. Practice, practice, practice. And using the empirical rule, it's really one of the most robust distributions in all of science out there. And finding these confidence intervals, +1 and -1, +2 and -2, and plus and minus 3 standard deviations, are actually very important to say something about what's going on in the process. Ultimately, we're talking about a business statistics problem here and what they used to call confidence intervals. But please be sure to send comments and suggestions to Dr. Frank's Finance World at jbawealth.com or fsmith@jbawealth.com. Thanks for listening to the Risk and Return, and best of luck out there. Have a good day. Bye-bye.